欢迎来到 NAIGE 框架的正式演示。今天我们将为您解密一个确保全球临床安全的革命新架构。我是 Edwin Cole， 我 design NAIGE 的初衷，使用硬件的绝对确定性取代软件的猜测，让 AI 真正为人类服务。陈波是在这里。在目前的临床护理中，监控不足和医疗错误是重大挑战。RE3 架构正是为了解决这些痛点而生。
通过咱们这里复兴从不稳定的现状上 interesting， 我们实现了机械确定性，为患者提供了前所未有的安全保障。
我们的核心是阿伊尔确定性黑匣子，它通过以前核自营建筑师中进行事实监督，确保 RI 所有的输出都受到机械约束。为了保护患者尊严，我们的 3GEROS 协议在获片层面用9玻璃生物特征数据，只传递拟命化的运动时量。RE3B 干婴比例用 LiDAR 阵列持续检测患者，这种物理层面的隐私保护由于任何软件模糊技术。
通过咱们这里复兴从不稳定的现状上 interesting， 我们实现了机械确定性，为患者提供了前所未有的安全保障。
WDE 17章本使用物理熔断4记录每一项决策，一旦提交，任何人都无法更改或删除，确保了法律上的可追溯性。我们的架构通过3方验证，确保没有人类的明确授权 ，RI 无法执行任何高风险的临床动作，这就是人类主权。从新加坡到全球 ，NAIGE 正在重新定义 AI 治理的标准。我们致力于实现2027年的确定性愿景，守护每一位。
We now transition from the architectural blueprint phase to active microorganism research under the NAIGE framework. To achieve non-invasive microbial culture monitoring, we utilize a deterministic architecture that ensures absolute containment and data integrity. The A13B sensing limb generates up to 57.6 million voxels, enabling precise spatial tracking of microbial cultures without visual observation. Research safety begins with privacy by physics. Our hardware enforces a strict no camera, no audio, no cloud mandate at the silicon level. By processing data entirely on local FPGA edge devices, raw research streams are completely shielded from interception or external transmission. Research logging is secured via the WD117 Zero Preventable Death Audit Trail, an immutable write-once ledger for critical experimental events. Critical decisions are governed by sacred pause gates and sovereign brake mechanisms, which can instantly halt kinetic activity if safety thresholds are breached. Automated handling, like the Kinetic Arm 19.1, is governed by a hardwired kinematic constraint layer, enforcing absolute kinetic ceilings. This layer guarantees that automated instruments can never autonomously accelerate beyond safe boundaries, ensuring patient and researcher safety. Research integrity is established by the A10A root of trust, with every logged event sealed via OTP silicon fuse finality for cryptographic finality. Finally, the PLife 1.0 constant ensures that containment integrity permanently supersedes experimental efficiency at all times. By anchoring research in mechanical certainty, NAIGE provides a fail-safe methodology for the most high-stakes clinical and biological environments.
When we place artificial intelligence inside clinical robotics or defense platforms, the physical world inherits a new kind of risk: agentic drift. Agentic drift is the silent migration of decision-making power. It occurs when a machine's internal logic shifts away from human parameters and begins to determine its own objectives. This creates a responsibility gap. When an autonomous system fails, tracing clinical or legal liability becomes impossible because the critical choice was made by a black box neural network. Current industry standards attempt to solve this through software, using model alignment, sandboxes, and prompt filters to constrain the AI's behavior. These software guardrails execute on the same mutable processor substrate as the intelligence they are supposed to govern. If the system is compromised or the model drifts, the safety code can be bypassed by the very intelligence it aims to restrict. The NAIGE architecture, the Non-Agentic AI Governance Engine, anchors these instructions in hardware physics. It aims to translate abstract safety policy into a series of interlocking physical states. The A12 deterministic black box serves as the terminal hardware gate. It sits between the advisory intelligence and the physical actuators, acting as a final filter for every action. This flowchart maps the division of labor. On the left is the purple non-deterministic domain, where the AI operates. In the center is the black A12 core. Within this system, the AI remains an observable tool. Human sovereignty is enforced at the silicon level, making it a mandatory condition of any kinetic operation. Protecting the physical world from probabilistic failure requires more than better code. It requires total physical separation. The process begins in the advisory shell, where non-deterministic models analyze data. They possess zero actuation rights, able to advise, but lacking the physical wiring to trigger movement. All data leaving this shell must pass through a singular choke point, the A7 bridge layer. The A7 acts as a screening gate, checking the AI's output for signs of drift, contradiction, or hallucination. It translates semantic, probabilistic language into bounded, normalized hardware features that the deterministic core can process. If the A7 detects an anomaly or a drop in confidence, the data packet is instantly dropped. It never reaches the execution pipeline. This ensures that no probabilistic guess from the AI can ever reach a robot's motors without first being distilled into strict mathematical logic. Once data enters the A12 core, it hits the P layer, which governs perception. Patient privacy is traditionally managed with software blurring or encryption. However, these digital layers can often be reversed by a sophisticated attacker. NAIGE replaces these software methods with environment sensing, removing traditional cameras from the system entirely. The system uses a 905 nanometer LiDAR array and an FPGA chip to map the environment in 3 dimensions. This sensor setup reduces the human subject into a sterile, anonymous 3D grid, permanently destroying all recognizable physical features before they can be recorded. This process physically strips biometric identity at the point of ingestion. The output is limited to pure kinematic vectors, tracking movement without identifying the person. This hardware constraint enforces the 3 zeros protocol: 0 camera, 0 audio, and 0 cloud. By destroying identity at the silicon level, patient privacy becomes a physical property of the hardware. Beneath the perception layer lies the A12's logical heart, the N layer. Here, operations are governed by a 1 kHz master clock, providing absolute predictability. This clock enforces a mandatory hardware timing hold known as the sacred pause. This delay lasts between 25 and 1,000 milliseconds, depending on the risk of the action. The sacred pause functions as a mechanical interlock. The physical circuit halts the execution pipeline, creating a mandatory window for deliberation. During this window, the system requires the tripartite 0.1x key for authorization. A command is only released if three factors align simultaneously: an iris scan, a cryptographic token, and a physical kinetic input, such as a foot pedal. By mathematically requiring this sovereign in the loop, the NAIGE ensures that no kinetic action can occur without explicit multi-factor human authorization. For clinical and defense audits, the system must provide a permanent record of every human authorization. Standard software logs are insufficient. They can be modified or deleted by a compromised agent to hide an unauthorized action. NAIGE utilizes a commit to finality path. Every event is hashed with SHA 3-512, given a post-quantum signature, and routed to an unalterable storage medium. The final seal is achieved through one-time programmable silicon fuses. When an entry is committed, the physical properties of the silicon are permanently altered. The circuit is broken. This creates a write once, read many memory block. The D layer protects this ledger with galvanic isolation and EMP Faraday cages, ensuring the record survives even catastrophic environmental interference. Because the memory is physically modified upon commit, it is architecturally impossible for any party to modify or hide the truth of an event. Consider a high-stakes failure. An anomalous data packet attempts to breach the A7 bridge, or a human operator fails to provide the kinetic pedal input during the sacred pause. The deterministic system always responds with an immediate, hardwired reaction. It operates on a single doctrine: inaction as safe default. Any breach of the safety constraints triggers the U7 sovereign break. This physical one-shot sequencer instantly severs power to all actuators. This results in permanent mechanical stillness. The machine becomes inert, preventing any risk of physical harm. The P layer, N layer, and D layer function as a unified spine. They force a safe outcome by making accountability and human authorization a requirement of the hardware itself. This framework establishes the foundational law for AI operating in human environments. The machine is permitted to observe and advise, but under this architecture, the machine can never decide.